All right, so today we're going to be looking at a very unique star called Polaris. As you must have seen in the previous video, Polaris is very unique because of its position, not because of its color or size or any other characteristics, but mainly because of its position. So as we learned in the previous video, Polaris is located directly above the North Pole of our Earth, of our beloved home. So it's directly overhead. It's at the zenith of our North Pole. So for that reason, when you observe the night sky, as you see everything crossing across the night sky or moving around because the earth is spinning, so you see all the stars and including the sun rising and setting, creating like a circular part. Polaris does not do that, mainly because it's located right on top of the North Pole. So the North Pole, when the earth is spinning around, the North Pole does not move because the North Pole is the earth's axis. So Polaris is stationary whenever you observe it. That makes it very unique, and that makes it a good star for navigation all the way back for centuries. Sailors and pilots depend on this for navigation, and that's what we're going to be learning about today. So you can look at Polaris if you are the type that is familiar with star constellations. Just if you're able to locate the Big Dipper and you draw an arrow through the edge of the spoon and straight up all the way down, you would meet or definitely see Polaris. So how is Polaris used for navigation or to know your location on Earth? So if you use this instrument, this altimeter, and you use it to view the Polaris, whatever the angle between your line of sight versus your horizon or the horizontal line, whatever that angle is equivalent to your latitude on Earth. Okay, we're going to learn a little bit more about latitude as we move forward, but I'm sure you know the first line of latitude is the equator, dividing the Earth into the North and South Pole, and then you have 90 lines of latitude above the equator and 90 below the equator as well. So simply put, if you were to be on the North Pole, Polaris will be directly over you, and that is at your zenith, and that would be 90 degrees. So the North Pole is 90 degrees. Remember, the North Pole is 90 degrees latitude, while the equator is 0 degree latitude, because all other lines of latitude are measured from the equator. So the equator is 0. All right, so if you are at the North Pole, the altitude of Polaris will be 90 degrees. But as you move away from the North Pole, you notice that the angle of inclination of Polaris begins to reduce. Let's assume you are somewhere right around here, and then you try to observe the North Star, which is also called Polaris. You'll see that there is an angle of inclination between your line of sight versus where you are, and that means you are somewhere around 60 degrees north latitude. And as you move further and further down towards the equator, you will notice that your angle of inclination keeps reducing. So if it reduces to 30, it means that you are on latitude 30 degrees on the Earth's surface, all the way down to 0. All right, so when you are at 0, your line of sight for the Polaris will be 0 degrees, which tells you that you are right at the equator. Now, below the equator, you don't get to see Polaris, which means the whole of the southern hemisphere do not get to see Polaris. That is why it is named the North Star. Only those in the north can see it. All right, again, as a recap, if you are on the North Pole, the sight of Polaris will be 90 degrees. If you are somewhere 30 degrees, you see that your altitude towards Polaris would be about 30 degrees north, which means you are somewhere 30 degrees latitude. And if it does not have any inclination at all, it means you are at 0. Definitely you are at the equator. Okay, so with those pieces of information, let's quickly review some regents question right here. Okay, so let's look at question number 1. We're just going to review about 4 questions, and then I'll let you do the rest for exit ticket. All right, question number 1 here says, for an observer in New York State, the altitude of Polaris is 43 degrees above the northern horizon. This observer's latitude is closest to the latitude of, so it gives you different cities. Right here, it gives you New York, gives you Utica, gives you Plattsburgh, and then Jamestown. This is gonna be a new concept, but I'm sure you guys will catch it. If you use your ESROT, page number 3, right here you see the map of New York State, where it says the generalized bedrock of geology of New York State, right there. And then you see these figures right here, and these figures simply connote lines of latitude. Let's make them a little bit more obvious. For example, you see 42 here, and 42 will correspond perfectly here with this line here. All right, let's try another one. 43, you see that 43 lines here. All right, 43 to 43. Let's try another one. You see 44 right here, moving across to 44 and all the way across. So these are lines of latitude, climbing all the way up. And 45 right here. All right, cutting through 45 as well. Cool. So simply put, our city, New York State and New York City, lies around 42, 43, 44, 45 degrees latitude in the northern hemisphere. So back to the question here. So the question is saying that the observer has observed that the altitude of Polaris is 43 degrees. So if it's 43 degrees, the question is which of the cities, which of these New York State cities lies on latitude 43 degrees? Could it be New York City? New York City will be all the way in the corner right here, close to New Jersey, and that is somewhere around 42 degrees. So definitely not New York City. Let's look at another option, Utica. 43 degrees. Look at the line of 43 degree and cut across. Yeah, you see Utica right here. Let me change. You see Utica right here. Cool. Let me make that a little more obvious so you can see that. Yeah. So Utica is pretty close to that latitude 43 degrees. So our correct answer should be Utica. But just to be sure, let's see if another option would work. So our option here is B. Pittsburgh. Pittsburgh is all the way up here, so it's closer to 45 to me. Definitely not that option. Jamestown is somewhere right here, so Jamestown is somewhere on 42, not 43. So yeah, definitely our correct answer is B, Utica. Question number 2. Which photograph of star trace was taken by an observer facing directly north in New York State? Again, Polaris does not move when you observe every other thing spinning around throughout the night or throughout the day. So as a result, it should be option A right here, with Polaris right at the middle. All right, right at the middle right there. So B is out of our way, C is out of our way, D is definitely wrong as well, because remember, this observer is facing north. So if it's facing north, then it should be directly be facing the North Star, Polaris. Question number 3. Base your answer to the following question on the diagram below, which shows the sun's apparent path as viewed by an observer in New York State on March 21st. And the main question here says, state how the apparent position of Polaris is related to the latitude of the observer. Simply put, the altitude of Polaris will be the same as the angle of inclination of Polaris. So the angle of inclination of Polaris will be the same as the latitude of the observer. That would be your answer for that question. Let's see. Question number 4, and I think we would wrap it up there so you can do the rest as your exit ticket. The accompanied data table shows the altitude of Polaris as recorded by 4 observers at different locations on Earth. Observer 8 observed that Polaris is 90 degrees. Observer B noticed that it's 30 degrees, C 30 degrees, and D 20 degrees. That's the altitude of Polaris. Which statement is best supported by the information on the table? Observer A was at the equator. No. If observer A is at the equator, then the altitude of Polaris should be 0, because the equator is 0. The latitude of the equator is 0. Observer B, option B, observer A and B measured the altitude of Polaris during daytime hours. Whether it's daytime or nighttime, the altitude of Polaris will remain the same. Yeah, Remember, Polaris does not change its position. That's why it's called the North Star. It's always at the north, directly above the North Pole. So whether it's daytime or whether it's nighttime, it makes no difference. Option C, observer B and C measure the altitude at the same latitude. B and C, they got the same altitude of 30 degrees. So definitely our correct answer should be that. Our correct answer should be C, because both of them measured it from the same latitude of 30 degrees. All right, so remember, the altitude of Polaris equals to the latitude that the observer is standing on. Let's look at option D, see if it's correct. Option D says observers B, C, D were in the southern hemisphere. You cannot see Polaris from the southern hemisphere. Sorry, only those in the northern hemisphere gets to see Polaris. That's why it's called the North Star. All right, cool. All right, let's do one more question. The group of stars known as the Big Dipper can be used to locate the North Star Polaris in the night sky. On the diagram of the Big Dipper below, draw a straight line arrow passing through two stars to indicate the direction of Polaris. Like I said, the Big Dipper is like a spoon, and then at the edge of the spoon, you just have to draw a straight line that will take you straight to Polaris. So Polaris should be something around there. And ladies and gentlemen, that will be it. I'll let you answer question 6, 7,